Hey guys, welcome back, and in this video we are going to taking a look at the Phantom Intruder picoCTF room, and you do able to see the description here, which is basically a digital ghost has breached my defenses and my sensitive data has been stolen. Your mission is to uncover how this phantom intruder infiltrated my system and retrieve the hidden flag. So that's our task. To solve this challenge, you'll need to analyze the provided PCAP file and track down the attack method. The attacker has cleverly concealed his moves in well-timely manner. Dive into the network traffic, apply the right filters, and show off your forensic prowess and unmask the digital intruder. Find the PCAP file here. You can see this is basically a network traffic PCAP file. Here is the my network traffic.pcap file that we downloaded, and we have to get the flag. And once I open that, this is the contents. And you can see whenever I am clicking somewhere, I was able to see some encoded contents here. Seems to be a base 64 encoded contents, so our task is to decode that. And we do have 3 hints available in the hints. Filter your packets to narrow down your search, and attacks were done in timely manner. Time is essential. So in this case, the time is what is essential. So as you can see, you have to sort these according to the time it is done. The attack is done in a timely manner, and you do have number, time, source, destination, protocol, length, TCP, segment data, and info is available in the Wireshark. So you have the time, right? You have to sort this according to the time. So once I right click here and click the follow and move to the TCP stream, I was able to see a base 64 encoded content, which I can say that there is an equal to at the end. This is most probably base 64. You can use tools like the inbuilt echo base 64 tool in Kali Linux for decoding that. So this is some part of the flag, right? So yeah, so we have to decode that. We have to, the attack was done here in a timely manner. So what we can do here is we have to sort this according to the time to get the results. So once I click here in the time gets sorted, right? So once I click it again, it is like before, right? So whenever I'm clicking here, you can see at the end we have the length information, right? Once I click the time, the length is now 4 12 8. It's sorted in this manner. So once I click again, this seems to be 8 12, right? So this seems to be some kind of sorted content, right? So once I click on any of these packets in the length equal to 8, I was able to see something is changing here, right? So here is the base 64 content, right? So once I click that, I was able to see the retransmitted TCP segment data from here in the left hand side. I'm just right clicking that, and I'm just clicking show packet bytes. So it is by default in none. So this is our content. So once if you want to decode, because this is seems to be the base 64, right? So once you click base 64, this is the decoded content, right? So yeah, like that you can just click some other contents like this, and let's right click here and click the show packet bytes, and this seems not a flag, right? So yeah, there is a length equal to 8 is what we are trying to click, and unfortunately that doesn't seems to be a flag in the show packet bytes, the exported content. This is the content there. So once you decode this into base 64, and this seems to be the content, so that means this is not what we want. Doesn't contain the flag. So yeah, by not to choose the length equal to 8, instead I'm just moving to length equal to 12. In that case, I'm clicking here and retransmit a TCP segment, and right clicking and show packet bytes. Here it is, guys. It's basically picoCTF, which seems to be the starting of any flag, right? So this is a base 64 content. You can just decode it by clicking here, and this seems to be the starting of a flag in the picoCTF, right? So after that, we can do things like moving to the next one and clicking here and right clicking and show packet byte. So yeah, here it is, guys. It's basically it was, right? So yeah, make sure you have to put this not into none. You have to put the decode as into base 64 to decode the content, right? So you have to click ASCII here also, right? So otherwise it won't work. Okay, so this should be ASCII. Okay, yeah. So this is it was. So yeah, like that, we can just sort that. And this is the next content. Clicking here, got the TCP segment data. So showing the packet bytes, and this is what we extracted before, right, in the terminal, right? So this is a part of the flag, right? So yeah, pasting that, and the next length equal to 12, and clicking here in the base 64, and retransmit the TCP's data, show packets as bytes, copying these, pasting here, and again just closing this. In here, the next length seems to be this, I think, here, show packet bytes. So yeah, this is something that we pasted before. So yeah, so it's this. Yeah, this is the next content. So yeah, at the end we have length equal to 4 is there. So yeah, let's check what is that. Showing, yeah, it's basically the end of the flag. Yeah, we were able to sort this according to this way, and we were able to solve this challenge, right? So this is how you can able to analyze the contents using Wireshark. So this video is not about solving this challenge, but also helps you to know how you can filter based on the time by clicking here to sort that, and looking for the length value, and clicking here in this option, and here, yeah, by right clicking into the data, and show packet bytes, and you also able to learn some decoding functionalities in the Wireshark. So it's by default in none. You have to decode it according to what encoding mechanism is this data is. So yeah, this is how you can identify without using any other external decoding tools. We were able to decode directly from the Wireshark itself, right? So yeah, I hope this video is informative for you, and thanks for watching, guys, and I will see you in the next one.